All right. Good morning, everybody. My name is Bill Ballew. I'm the Chief Technology Officer for DreamWorks Animation, and I'm absolutely thrilled to be able to kick off Open Source Days. By the way, the talk I'm going to give today is completely AI-free. And I know that's unheard of in this day and age, but if you will just indulge me, we will go through a 2-hour journey with MoonRay that fortunately I've cut down to about 20 minutes. So David, don't freak out too much. So we're going to talk about how MoonRay went from a studio tool to an open source tool, and then now, most recently, the latest project to join the Academy Software Foundation. I'll touch a little bit on the history, the evolution of the project, some lessons learned, and the community that we've been building along the way. We at DreamWorks are so proud for MoonRay to take flight and become one of the projects, the incredible projects that are part of the Academy Software Foundation. We really think it's a natural progression for MoonRay, and we're so excited to see what that journey is and how that goes. So going back just a few years, MoonRay really had its debut in the studio as sort of a trial by fire on our 2019 release of How to Train Your Dragon: The Hidden World. And all the richness of that movie was rendered with MoonRay. So it has since then served as a critical backbone for the DreamWorks feature pipeline, pushing boundaries, establishing new looks, and really bringing our filmmakers' vision to life. And you can see from our slate of films here, there's a lot of diversity in that slate. And MoonRay has really been hardened by each one of those movies and by thousands of artists, all delivering hundreds of millions of pixels to theater screens worldwide. And what I want to do is show a short clip that highlights some of the imagery that we have from MoonRay, but it also kind of reflects the journey that we've been on as well.
Don't give up.
Come on, kid.
Get your butt back up in the air where it belongs.
Gentle motivation is a mom skill. You'll learn it.
Atta boy.
Just might kiss the sky.
I don't know about you, but as a parent, that clip gets me like every single time. I think my teams also claim that a little gentle motivation's also a CTO skill, and maybe we'll see a little bit of that as we go through. So the imagery that you saw in that clip and the imagery from all the films that are represented on this slide really represents over a decade of concentrated engineering, but also artistic collaboration with all of our artists within the studio. And what that's let us do is to just explore fantastical worlds and really tell the unique stories without any sort of limitations. At the core of all this is MoonRay. That is our state-of-the-art Monte Carlo path tracing production renderer. And from the earliest designs that we had of the renderer, we knew it had to really focus on efficiency and scalability. We work at a film scale, obviously, but we actually work at a multiple film scale, working on 5 to 6 films at any given point. So we really had to focus on maximizing the usage of all of our compute resources. The other thing that at DreamWorks, we don't have a typical house style. So that meant that our renderer also needed to be a chameleon that could support a full range of filmmakers' imagination, from organic, hyper-textured, photorealistic worlds of How to Train Your Dragon, to heavily illustrated, hand-drawn looks from a movie like The Bad Guys. So let's look at this. So the design for MoonRay had to first deliver a wide range of visual languages, including what ray tracers are typically really bad at, which is non-physical reality. It had to avoid restricting artists and give them full creative expression, and it had to not sacrifice any underlying speed or performance. So that should be a piece of cake, right? With a little gentle motivation, right? So let's go a little bit deeper and look at how Moonray achieves the flexibility and the performance. So there are three kind of core aspects of the software stack. The first one is Moonray itself. And so this is the workhorse. This is the path tracer. Every render has a bit of a personality. Ours has this one. It's to keep all the lanes of all the cores of all machines busy all the time with meaningful work. That meant that what we were really focused on was a data-oriented design, something that you'd see more typically in a game engine. Every byte matters, interfaces needed to be extremely thin, and we took a ruthless approach to eliminating data structure redundancy. From there, Moonshine sits on top of that, and really this is an expansive, battle-tested collection of layerable production shaders. It provides incredible, intuitive, and deep material systems that really support a wide range of styles. But rendering billions of rays requires more than just a smart renderer. We also need to have a scalable computation framework, and we call that framework Arras. And what that does is it allows us to take both the local compute on an artist's workstation and pair it with a distributed compute with a set of machines that may be a cluster of machines available to that artist. So even for interactive use cases, the artists have access to far more compute than would just be on their single box. So here's an example of that, where we have an artist that changes a light or tweaks a material in their viewport. Arras steps in, and what it does is it distributes that work onto a cluster of other machines, and then it streams the results back to the artist's workstation. So the framework allows us to really scale seamlessly from both real-time previews all the way to final renders. All right, let's look a little bit at the development history just to give some insights into the journey that we've been on. And you really have to go back a few years. Back in 2012, we started looking both at the creative ambition from the studio in our theatrical slate, but we also were looking at what the trends were in technology at the time. So when we looked at 2012, we saw one film stand out in our slate that had a lot of ambition in it, and it was How to Train Your Dragon: Hidden World. We knew global illumination, soft shadows, physically accurate bounce light were becoming creative mandates. And that all sounds really obvious today, but that was not completely obvious back in 2012. And it was at a scale that we had never done before. At the same time, what was happening in the technology landscape was that the CPU manufacturers, well, they stopped our free lunch. So we were really used to, at the time, every 18 months, clock speeds were doubling, and we got to take advantage of that. And suddenly that stopped. And what we had instead were core counts were increasing. And we started seeing the expansion of SIMD vector units. Again, you have to remember this was 2012, so not today. The challenge for us was not to leave any of that processing power actually just sitting idle, especially the vector lanes. And the extra challenge on top of that is that path tracing itself is not trivially vectorizable. So we realized there was an opportunity here, and one for us to create a clean slate architecture. So in 2013, we actually made the decision and we launched the project to kick off our own renderer in-house. By the end of 2014, we actually had a proof of concept, and we kept that mantra that I mentioned very much in mind as we did. Within a couple of years, we committed the first show, and as I said, it was How to Train Your Dragon: The Hidden World. And now that show, it was a little more obvious what it was going to be. Millions of bioluminescent lights, thousands of flying dragons, and dense, complex environments. It definitely had a lot of ambition. It was also the ultimate proving ground for us, massive geometric and lighting complexity, which was exciting and terrifying. So what we had was an R&D project that now it became a production necessity, and we were committed to that release in 2019. Now, I'm very happy to say we actually achieved it, and that film got out, thankfully. So we continued to push new films, more creative ambition, and we had a realization at some point that really Moonray could be valuable much more broadly and even across multiple industries. And we thought it could actually become a much better product in the open source community. And if you just look at some of the successes of things like OpenVDB, you can see that that was truly is the case. So we decided to untether Moonray from our studio, and in 2022, we had the decision to open source it. And of course, that would later lead us to where we are. as the latest member project of the Academy Software Foundation. All right, so once we set off on open source, we knew it wasn't just going to be as simple as exporting our repository. We have an environment where tools are tightly integrated into our pipeline. We reuse underlying libraries and proprietary data formats. So we couldn't open source the entire tool chain, the entire pipeline, and nobody would want us to either. So as we step through this, we really prioritized a number of focus areas initially. We looked first at standardizing the build system. We needed to separate it from all of our internal structures and our processes. And we needed to be standalone for the community. We then reduced a lot of our internal studio dependencies. That meant specializing or separating some of our specialized shaders, especially those that were tied to internal formats. We have a very modern code base, which is great, but we did focus on cleanup of that code base, and especially around consistency. And then there's documentation. Documentation is the thing that just always gets deprioritized and held off for last in a production environment. But we wanted that the first time a community developer cloned our repo, we wanted to make sure that it was well documented and that they had a path to be able to work with Moonray right away. None of this was overnight. We greenlit the project to open source in January of 22. In August of 22, we actually announced it at SIGGRAPH. And it still took us several more months of untangling and some hardening, where we had the first public release of this in March of 2023. So what does the journey look like so far? So from that point, we really tried to keep our foot on the gas. We had, in the last 3 years, we've had 12 community updates, actually 13. We had one this week, so 13 updates. And we had progress in kind of these three main areas. The first one is around building the community. We built it, will they come? And what we found is we actually had a lot of very eager enthusiasts that were really eager to learn and to experiment, and we wanted to leverage that. The most common question we got was, is there a Windows port? And we said, there can be. And then we also had a lot of professional collaborators that showed up, and it was fantastic because they weren't just there looking at individual bugs, but they were actually there actively looking at architectural issues, and they were looking at things that we just never encountered in the studio. And so this is exactly why we wanted to open source it. We wanted these different perspectives to come in and look at what we had in Moonray. Now, that all led us to some key lessons. And I'm going to say documentation again, because documentation needs to be a way of life for an open source project. As soon as the documentation goes out of date, your repository is effectively broken to the outside world. The second thing that we learned was around maintainer support. So this is our own developers. And what they now had was added responsibilities around code reviews, technical steering, community management, all the things that are really critical to make sure that we have an engaged community. But we had to give those maintainers, our developers, some room to balance that work with their day-to-day work that they have to do. And then the last thing here on lessons learned, we had to figure out how to handle contributions in a way. And we needed an automated bulletproof framework for contributions. We actually exposed our internal unit test system, and we allowed the community to add test cases to that framework. This is 100% critical for both stability and to avoid performance regressions. And for us, it was also really important because it helped maintain trust of our artists and our studio as a whole to know that we weren't just going to go off and break Moonray in some sort of random way. The third area is around measuring success. And this is different from the way that it works within the studio. In the studio, it's all about us delivering capabilities to our artists and to our productions. But here it's a little bit different. And it's really easy to get caught up in the vanity metrics of the open source repositories. It's not about stars. It's not about the number of fork counts. It's something much deeper than that. And what we found was the success that we really felt was meaningful was around the contributions and the independent innovation that was happening from the community as a whole. When we started seeing contributions for Moonray working on Apple Metal, or working on Windows, that suddenly became an ultimate metric for us of success and engagement within this project. And really the short of it was that we had people that were helping us move Moonray from a DreamWorks tool to an industry asset. So Moonray was still really seen as a project managed by a single studio at that point. And so we realized that there was a need for us to look for a permanent home for Moonray, because it was creating friction for other studios and other groups to come in and contribute to it. So the Academy Software Foundation became just an obvious place for us to look. We were one of the founding members. We are also a big contributor for the foundation. But the transparency and the neutral platform that the foundation provides is really key, and it helps supercharge the engagement and the adoption of these different projects. So we wanted that too. The community in the foundation is exceptional. It is absolutely the gathering of the best and brightest in our industry. And in the foundation, we can create far more than we can create by just one company. And so that those different perspectives, the diverse thinking, the diverse use cases that all come together is really exceptional. So Moonray already leverages a number of other projects in the foundation. And as David has said many, many times, the true magic of the Academy Software Foundation is not that we have projects in separate neutral buckets. The power is the cross-pollination that actually happens and that they can strengthen each other. So we think that there's a really interesting and somewhat unique proposition here with Moonray in the foundation. And that is that it becomes a practical integration point for the entire ASWF landscape. We have a native OpenUSD Hydra delegate in Moonray, and we think that can really be a good point to kind of pressure test the scale of assets in a viewport. We think with our MaterialX support that may be a baseline to ensure material definitions can transfer accurately between platforms. And we believe that we can really push on performance with some of the underlying libraries as well: OpenVDB, OpenColor.io, OpenEXR, and OpenImage.io. And finally, a render really has to be deployed cleanly and write data efficiently. So testing with things like Res and with OpenQ could really help harden the deployment tools for massive scaling. So I think in the end, Moonray shouldn't be seen as anything that's competing with the other projects for resources. It really complements that, and I think we can see it stress test and really validate the entire ecosystem. So we've had a number of early wins. We've only been part of the foundation for a couple of months, and we've already seen some good early wins. We've been collaborating closely with the CI working group, and we have now Moonray tied into the build infrastructure. And in fact, just a few days ago, we announced a snap installer for different versions of Linux. We have monthly TSC meetings that they have started. We have 119 channel members now, with the community growing. And we've seen a lot of increased community and vendor engagements as well. We've been talking to the Foundry, for example, of integrating the Hydra delegate for Moonray into some of their products. We've seen community members contribute patches related to Houdini 21 and Hydra 2.0, and hopefully there's more to come on that shortly. And then we have an ongoing collaboration with Microsoft to get Moonray running on Windows. And there will be more on this in the BOF that is tomorrow, hopefully with some demos as well. And then we have an early collaboration going with the Blender Foundation, who have a test framework for comparing OpenPBR implementations, and we're working to get Moonray set up in that framework. So that's just in the first couple of months. We are so incredibly excited and encouraged to see what the progress is that's there. So just in closing, you know, a wise panda once said skadoosh, and I think that puts kind of a period on it. A couple final thoughts here. One, we have at DreamWorks, we have a long history and commitment to the open source and the Academy Software Foundation community. As I said, we're one of the founding member companies. We had the first project accepted into the foundation, which was OpenVDB, and we are absolutely thrilled to have Moonray accepted today. We believe deeply, deeply in the collaboration, the partnerships, and just the strength of this collaborative community. And I'll also say we are all just tool builders at heart. And I think the greatest thing as a tool builder is to watch what you've built be used in ways that you can never imagine just on your own. And I think that's what we're looking for next, that There could be new pipelines and visual effects using Moonray. We could see transforming design workflows in other industries. And we're hoping that it can become the foundation for cutting-edge graphics research in academia. So just to close out, I'm gonna leave you with a trailer for one of our upcoming films, where we're again kind of pushing the look, and Moonray is just a critical aspect of achieving that. So please enjoy. This is the trailer for our upcoming film, Forgotten Island. And thank you all for your time.
I'm Joe. I'm Risa. Do you want to be best friends? Cool.
Let's make it official.
Sorry, I can't do a blood oath.
I'm not a psycho.
I've never had a best friend before.
Me neither.
Let's go!
We're gonna be best friends forever. Right?
Forever and ever.
You don't have to go all the way to the US for school.
It's what my parents want.
It shouldn't be their choice. It's your life. But hey, we made some good memories. Risa? Something's happening! No way.
Won't you come see about me? I'll be alone.
Hold on!
Won't you come see about me?
Where are we?
The Forgotten Island is a dangerous place. The longer you're here, the more memories you'll forget.
We would forget everything? Even each other?
Forget about me.
This is our entire friendship. We gotta find their way back home.
Don't you forget about me.
We're running out of time! Hey, it's okay. Listen to me, Risa. I just have one question for you. Who let the dogs out?
No, not right now.
Come on, answer the question. Who let the dogs out?
Okay, thank you.
We need a game plan.